Hi students, welcome to the ABK Chemistry channel. Today we are going to discuss one of the important topic in chemical kinetics chapter. So before going to discuss about this topic, please subscribe the channel and activate the bell notification icon for further updates. Okay, now coming to the discussion about the topic, that is half-life of a reaction. What is half-life of reaction? First observe the statement here. The half-life of a reaction is the time in which the concentration of reactants is reduced to one of its initial concentration. One half its initial concentration. See, what is the meaning of that one is nothing but generally you have to take one chemical reaction. In the chemical reaction, the reactants will be converted into products. That will be generally takes place. At time is equals to 0, the concentration of reactants, first I am going to taking 100% and the concentration of products is 0%, it is there. Time is equals to 0 is nothing but still the reaction is not started. Okay, that time the concentration, first 100% of reactants are there. Okay, if the time will be start means the reaction will be start and the reactants will be converted into product. That will be generally takes place. Now, if the time is going on generally, the concentration of reactants is reduces and the concentration of products is increases. Is it or not? See, initially how much percentage is there? 100% is there. That means to convert, what is the half of 100 is nothing but 50%. That means to convert into the change of concentration of reactants from 100% to 50%. The change of products from 0% to 50%, for example. I mean, for this change, what is the time will takes place? The time will be known as a T half. See, what is the definition there? The half-life of a reaction is the time in which the concentration of reactants is reduced to one half from its initial concentration. For initial concentration is, for example, 100% you have to think, for example, and to convert 100% to 50%, what is the time takes place? That time generally considered as a half-life of a reaction. Okay, how? For example, half-life of reaction we have to derive for first order reaction as well as zero order reaction is also. See, coming to the first discussion about zero order chemical reaction. Half-life of a zero order reaction. See, generally keep in your mind students, the half-life of any order reaction will be derived from their integrated rate equations. Already we have discussed integrated rate equation in previous videos. Please subscribe the channel and you get that videos also. Okay. Now coming to the first half-life of a zero order reaction. Already I told that half-life of a zero order reaction will be derived from their integrated rate equation. What is the integrated rate equation for zero order reaction is nothing but that is K is equals to, that is rate constant is equals to initial concentration of reactants minus concentration of reactants divided by T. This is the integrated rate equation for which order reaction? Zero order reaction. See, this I am going to take in as a equation 1. This I am going to take in as a equation 1. Okay. So, it is integrated rate equation for which order reaction? Zero order reaction. K is equals to initial concentration of reactants minus concentration of reactants divided by T. T is equals to time in seconds here. See, what is the condition I am going to take in here is nothing but T should be how to take as a T half, that is half, that is I am going to take in half-life of reaction. So, the time should be converted into half of its initial time, comma, and the concentration of reactants, what is there here? The concentration of reactants. See, concentration of reactants, what happens? Reduced to exactly half of its initial concentration. That means concentration of reactants is, you have to take initial concentration of reactants divided by 2 you have to take. Is it or not? See, time will becomes to T half. If time is equals to T half is nothing but concentration of reactants will becomes to what? From its initial concentration half of the reactants will be converted into products. That is divided by 2 you have to do. Substitute these two values in equation 1. Substitute in equation 1. See, you have to, in the place of T I am going to substitute in T half. In the place of concentration of reactants I am going to substitute in this value. So, what I am getting here? Now, K is equals to initial concentration of reactants minus, in the place of R I am going to substitute in this one, that is initial concentration of reactants divided by 2 divided by In the place of T, I am going to substituting T half here. In the place of T, I am going to substituting T half. Okay. Now, see here, I am going to erasing this part, and next see here. Now, T half I am going to sending this side, K I am going to sending this side. So, what I am getting here, T half is equals to, and 2 is multiplying with this one. So, what I am getting here, so 2 into initial concentration of reactants minus initial concentration of reactants whole divided by K is coming this side, already 2 is there here, I am getting 2K, okay. Now, here plus 2 initial concentration of reactants minus initial concentration of reactants is there. In this and this one gets cancelled, and remaining one initial concentration of reactants is there here. Now, what is the formula? Now, T half is equals to initial concentration of reactants divided by 2K. Very important relation, students. I am going to take this is equation 2 for example, just that is the end of the last equation, okay. See, half-life of a zero order reaction is equals to initial concentration of reactants divided by 2K. In this equation, what it is understand is nothing but, see, the half-life of a reaction is always directly proportional to initial concentration of reactants, and half-life of a reaction, which order reaction? Zero order reaction. Half-life of a zero order reaction is directly related to initial concentration of reactants. Half-life of a reaction is inversely related to rate constant. It is there down. That means, for example, if you take the reactants will be converted into products, for example, if the initial concentration of reactants is, for example, how much is there? For example, I take initially 50% is I take just one initially, and is 0% is there initially. See, if you increase the initial concentration of reactants, the rate of the half-life of reaction is also increases. Why? Because the half-life of zero order reaction is directly related to initial concentration, and half-life of reaction is inversely proportional to rate constant. They will ask question for one more question. They will ask, for example, in your board examination generally, the initial concentration, the half-life of a zero order reaction is doubled when the initial concentration of reactant is doubled. The half-life of reaction, what happens means the half-life of a zero order reaction is also doubled. Like that they will ask. Okay, the initial concentration of zero order reaction is doubled. The half-life of a zero order reaction, what happens means it is also doubled. Why? Because both are directly related to each other. Okay, so like that. And the half-life of zero order reaction is inversely proportional to rate constant. See, this is the final equation, students. You have to keep your mind. Thank you so much.